Hey guys, it's me again. Today we have a Rotel Power Amplifier RB1070 that came in for some repair. Um, if you hadn't noticed already, I have a new angle now because for a very simple reason. People have been complaining that it's apparently too shaky, or my videos they get too shaky there. But I'm looking at my camera right now and it's still kind of shaking. So I'm gonna try the best that I can because I'm not a multi-millionaire, so I can't invest in $1,000 whatever gimbal machines and stabilizing things. So this is what's gonna happen for the time being. My plan is I might get a tripod, set it up like this so that you can see what's happening below. Um, what else is there? Yeah, so because people have just been complaining a lot than I expected, and just really just being complaining a lot about it, and not being really supportive. So most of those comments, actually, I took them down, but there's probably going to still be a couple up, so I'll have to take those down as well, because I don't want to hear people telling me, oh, your video sucks because it's too shaky. Why do you watch that? I mean, seriously, if you don't like how I film my videos, just go somewhere else. What do you want me to tell you, But yeah, I know there's going to be people always like that because they're just keyboard warriors and they just have nothing better to do in their lives, right? So I'm not surprised. But anywho, for the people that do care and, they don't complain, I thank you for not complaining. It saves me the headache of going through comments and deleting them because, I just don't like seeing that kind of stuff under my videos. But anywho, going on with today's video, like I said, we have a power amplifier RB-1070 from Rotel. This is an amplifier actually from the same guy that I fixed the Bryston. So if you watch a couple videos back and you look at the Bryston that I repaired, this is actually another amplifier that came from the same owner. And this one, apparently, it powers on, but there's no output or no sound output. So right now you don't see off to the side, but I have this plugged into my dim bulb, my auto transformer, and my isolation transformer, and I hope there's no shorted outputs. But given my experience with this kind of stuff, I wouldn't be surprised if there was. And on top of it, the outputs, which are over here and here, I'm gonna take the top off, and you'll see eventually. The power outputs are Sanken transistors, and I know that might be hard to find, so might have to get replacements or cross whatever replacements for them if there are any that are blown up. But I hope it's not the case. First things first, actually, I'm gonna get my multimeter because I gotta adjust my auto transformer to 110 volts AC because I had lowered it for something else. So I'm gonna get my nice Fluke graphical multimeter. This is a tool that you might have seen before. If I didn't, this will be the first time that you'll see it. This is a nice tool that I bought off Marketplace. I got it for a really good deal. And this thing has just been phenomenal to me. Only thing I did to it was I replaced the batteries. Otherwise, the tool works great. So I'll put that there. Just get the probes out. So let me get the Fluke original probes. Yeah, here we go. Oops, let's see. Because I have a couple of probes in here. So let me just get the probes out. You might see this off camera. I'm not quite sure how much I'm going to be getting from this angle here, as you can see. So when I look at my footage after, I'll see if this is a good place to put my phone, my camera, until further notice. So I'm just going to put this here. Those are my probes, and this I found out where they were because this was a while I was trying to find them. These probes are very useful if you work in small spaces and on small things. Very, very nice to have. And sometimes also, especially when you deal with boards that have conformal coating, so any protection, this will puncture right through the conformal coating and it'll, hit the pad or whatever you want to hit. Compared to the normal probe tip, this one could puncture it, but I find that sometimes this doesn't do so well. This is much pointier or sharper, so it works all the time. So I have this to the side. But yeah, let's fire this multimeter up because I'm just checking here. I don't think I need, no, I'll leave this in the bag for the time being. So, another thing I did for this tool was I changed the batteries because batteries were shot when I got the tool, so I wasn't surprised. So we're gonna plug this in like that. I'm gonna set it to AC. And also, if you couldn't tell already, there's a nice backlight on this thing, which I like a lot. Compared to all the other multimeters that I've had before, this is the first multimeter that I have that actually has a backlight that stays on and doesn't turn off automatically, you know? So, because all my other multimeters and my original Fluke multimeter, this guy over here, actually I'll show you quickly. This guy right over here, this guy, it has my name on it and everything, but you could tell that it's been through quite a war scene, you know, because broken plastic and stuff. But you know what? This thing still works to this day. I turn it on, and it does what it has to do, except for the fact that there's no backlight, you know. So after a while, when you work on stuff, the backlight and the bigger screen, you'll see it helps a bit. So, but I keep it, even though it looks like in, you know, a bit rough shape with the broken plastic. I still keep it because it does work, you know. So, but yeah, I'll put this to the side because I won't be using this one today. So, like I said, I'm going to adjust my auto transformer to 120 volts AC. Let's see, here we go. Yeah, so as you can see, it's set to 18. Now you're going to watch me. I'm going to crank this up to 121. So I'm going to bring this up to 121. 60 hertz all the time because that's our nominal frequency here in North America. 33, 35, 36, 37, 38. There we go. The amplifier is not turned on right now. I'm just, like I said, I'm adjusting my auto transformer off to the side to bring it up to 120 volts, 110 volts AC, so that I can power up this amplifier and see if there's anything seriously wrong with it. Because that's one thing with this kind of stuff. You don't want to plug it in straight to the wall without any sort of protection, because you don't know if there's something seriously wrong with it. Let's say there's something seriously wrong with the amplifier, you plug it to the wall. Not only do you trip circuit breakers, you know, potentially on your house, but you can also damage more components inside, you know, your unit that you're working on, simply because you didn't put any protection on it, right? So a dim bulb and an isolation transformer and an auto transformer like this are, in my opinion, necessary when doing this kind of work, because without it, you'll be pretty much lost, you know. But anyway, so now my auto transformer is set to, I have it set to 121. So, and also if you look at my multimeter, actually they call it a graphical multimeter, so it's not a normal multimeter. You'll see that there's a little window here on the side that shows a how do you say, it's like a mini oscilloscope, because what this tool does is the primary function is a multimeter, but at the same time it has a built-in oscilloscope. But the oscilloscope in this thing is not very, I wouldn't say precise, but it's not obviously a handheld scope. It's a lot different. So this is just to give you a rough idea of what's happening if you see there's any noise or, you know, stuff like that. If you want to see something with a lot more precision, you obviously would go use an actual scope, because this is not a scope. Like I said, it's a multimeter. But if I switch to the scope, let me see if I can show you this. Let's see. Yeah, okay, no, this is a different mode. Let me just see, because the first time I'm doing this display. Trend, I think it is. No. Let me see. Let me just flip this up for a second, because let me see if I can just put on view. Here we go. There you go. So this is the oscilloscope in this thing. Like I said, it's not very, I would say it's pretty darn precise, but I mean, it's not like a scope, right, where you can change the impedance and, you know, your probes and everything like that. So again, this is just to give you a rough idea what's happening. But yeah, so I like it. I find it useful for quick debugging, because then if there's something more serious, I'll take the scope, use it, and, you know, test whatever I have to test. But for most things, I would say this is pretty darn good. And like I said, if I need the scope, I'll just use it. But anywho, so let's go back to the normal view. Here we go. So 121 volts AC. So our auto transformer is set correctly. I'm going to take this off. I'm going to put this off to the side. Turn it off for the time being. We're going to see what happens when I power up the amplifier. We're going to see if there's a serious issue with this thing. It's on the dim bulb, so let's go ahead, fire it up, see what happens. Power. So it's on, but maybe I think there's no relay that clicks, so I guess that's a good starting point. Bridge mono. Yeah, see if I power it off now again. It's gonna, yeah, okay, so that goes down. That's good. Protection light is not on, which is a good sign actually. So let's see. Okay, let me start by taking the top off. I'll unplug it. We'll start by taking the top off because I'm not sure what to expect, to be honest with you. Let's see. Okay. All right, so let's just screw this down. Total trickery, I don't need that. It looks really relatively simple. Yeah, Rotel Corporation, this is made in China. It says on the back that this thing is capable of 400 watts output. Whether or not that's true, I have no idea. But I think these units are pretty well built, actually. So what I'm going to start to do, yeah, we have screws on the bottom. Okay, so we're going to take the 2 screws off here, the 2 on the back, and then there's probably going to be another 4 on, 2 on the sides. So let me grab my screwdriver. Okay. I'm going to go ahead, start unscrewing. Let's see. Like I said, I have no idea what to expect. This is the first time I'm opening this. It does turn on, but again, my customer said that there's no sound coming out of it. So we'll take a look and see what's happening inside. I got my metal plate to catch all the screws. It's already popping up the cover. Here we go. So I got my metal plate here, but now I gotta flip it upside down because there's screws on the bottom as well. Yeah, big time. So more actually. Okay, so we have 3 and 3 actually. So let's take these off. So here we go. Are these the same length? I think so. Just double checking to see the screws are the same thing. What I do is I'll bundle them together like that, yeah. Open it up. Okay. Open up this one. Like that. Let's see. Let us see. There's actually even more on the back. Okay, there's another two. So there's actually the majority of the screws are on the bottom. So you take the cover off. Actually, no, wait a minute. Is this part of the cover? No, this is not part of the cover. Okay, so let's flip this back over. And we're gonna see what is going on inside this thing. So here we go. Take this off. Oh boy. Okay, let's see what's going on. Oh, hey, here we go. Dust, as usual. I haven't gotten an amplifier yet that has been no dust. So I can see that we have, not sure why they have this big heatsink in the front. I think that's actually there for looks, believe it or not. Because I don't see it serve any real purpose. Yeah, this thing looks like it's never been inside. Nobody's ever been inside this darn thing. Okay, I'm just looking to see if there's a relay anywhere. Maybe that's what I'm missing. So it's a dual mono, if I'm not mistaken. Yeah, we do have protection. That's this guy here. I'm just looking around. This is a relay, I think. It's not a protection mode. Okay, let's see if any of the fuses are blown. I think, I see it right away. So we got a blown fuse here, I think. And I think we got I'm not sure. So let's see. 5 amps. So these are 5 amp fuses, but I think I see one that's blown. Yeah, so let's start by powering it up again. We're gonna see if we have power. Now the relay clicked. There we go. Yeah, now the relay. Interesting. Okay, that's weird. Okay, there's nothing else. No, I was just wondering if there was something else. But the relay actually is clicking. It's this one right here. It is clicking and doing something, because if I put my hand on it, yeah, it's clicking away. So there's a relay over here under this thing. And it is turning on and off. So let's check to see if we have voltage. So being this is a dual mono design, yeah, I'm gonna use the bridge rectifier minus as the reference. So let's see what we get in terms of voltage. Let's see our voltage on this thing. So I can see just from the glimpse. I'm putting it down so you guys probably can see better than I am. But let's put this guy here. And let's see if we have voltage. 50. Aha. So one of the fuses is blown, as I thought. So this one's blown. 50, let's see here. 102. Ooh, this one might be blown too. 50. I think this one's blown as well. 50. Yeah, there's nothing there. If I go on the other side, I'm going to use the other side as a reference. Now, the fact that the fuses are blown kind of concerns me, because that usually tells me that there's outputs that might be fried. 100. 100, yeah, you see, here we go. So this fuse is okay. Oh, let's see. Interesting. There's nothing here. 0, 0. Interesting. If I do a quick continuity test, so we have one fuse that doesn't seem to be outputting nothing. Yeah, we can just check. Yeah, so this one is probably gonna do a little beeping. Yeah, and this one's probably gonna be good. Yeah. This one's probably going to be open. Actually, no, this one seems to be good. Interesting. This one's going to be open. Yeah, open. So we have one fuse that's gone open, but now, why did it go open? I'm just peeking over to the side, seeing if I have, do I have a 5 amp? What I'm gonna do is I'm gonna power this down, and I'm gonna see if I have, I don't think I have a 5 amp fuse for this thing, but what we're gonna do is we're gonna put in a slightly smaller fuse, and we're gonna check to see if there's a short somewhere in the circuit. I'm just checking my voltage because, oh my god, these caps are still charged. Okay, I'm gonna pull the plug on the back because I don't want to sap myself, because these 63 volts, so they're probably holding about 50 volts on each cap. So what I'm gonna do is we're gonna drain it, because it's still, oh my god, 100 volts each. These caps are still charged. 50, nothing. Caps are still charged, so I'm gonna be careful there. So T, which means delay, so it's a 5 amp slow blow. These fuses here, yeah, so each fuse here, there's 2 and 2. Each one is 5 amps, 250 volts, that's what it's rated for. Yeah, it's basically, one of them is open. Now, whether or not there's a short on any of these transistors, we can start by checking that. Actually, we can see there's a short on the transistors, but I don't know if that's going to be the case. I'm just going to peek around somewhere here. I'm going to look at some other stuff. Just going to see there's some other stuff maybe that might be interesting. This looks like this might be for the bias adjustment, these little pots here. So, and it looks like, yeah, these transistors are, the legs are going under and they're being bent and soldered onto the board like that. So, let's see if we have any shorts. I want to see if we have any shorts. Okay. Are these all PNP? This looks like first 3 are NPN and other 3 are PNP, I think. I'm not sure. Yeah, emitter collector base. It's actually on the silk screen. I can see it here. Emitter collector base, but it doesn't say if it's a PNP or NPN. But I think this is NPN and this is PNP. Yeah, I think. And they're Sanken power transistors, so trying to find replacements for that might be a bit of a problem. I'm just thinking now something. Because the fuse is blown. I'm going to start by taking the fuse out. I'm going to put another one in, and we're going to run it on the dim bulb, and we're going to see if we have a short somewhere. These caps are still probably charged, which is scaring the hell out of me. And they're going to stay charged for quite a while, I'm guessing. So this is now, that's all on there. So what we're going to do is we're going to just, yeah, we're going to try to pop this guy out as is, because he is blown anyways. I think this is supposed to be shorted here, no? Let's see. Yeah. So let me grab my pick tool. Actually, you know what? I'm gonna try one of my other tools here because I think it might be able to get it out. Let's try our grabber here. Might be able to get this out. Let's see. Nah, see, because it's on there pretty good. So let's see if we can get it out with our trusty pick tool. Yeah, it just goes to show you that these caps, they charge for a hell of a long time, so you want to be careful. And what you do here, here you go. So, yeah, here we go. Now what I'm going to do is I'm going to grab my plier, and we're going to get them out of there. I want to make sure, be careful with what we're touching. There you go. So, yeah, this fuse is blown right open. T5, 250. Yeah, so 5 amp delay, 250 volts. I'm going to check to see if I have a replacement here for that. I don't know if I do. Let's see. Don't know. I don't think I have. I'm going to check here. So, I have a 6.3, which I think is probably going to be too big. Let's see if we have something else here. It's a fast blow. It's not going to work. So I'm going to put in for the time being. Kidding me. These are 2.5. So I don't have the right fuse, but just for testing purposes, this is 2.5. Yeah, and delay. So this is 2.5. 2.5 delay. So we'll put this in, and we're gonna see what dim bulb is on. Okay, so we're gonna plug this in. We're gonna power it up with the dim bulb. Interesting. So what we're gonna do is we're gonna power this on. Yeah, okay, dim bulb is not dimming all the way, which is good. Sorry, not it's not staying lit, which is very good. Let's see. Could it have blown up just for the simple fact that it was tired? I don't like the fact that this is reading. That's 100. That's 43. Let's see something. I want to see from here to here. It doesn't make sense what I'm testing because it's across the same thing. Just trying to picture in my head how this is wired. We have, yeah, so this is probably going to be, yeah, so our minus and plus are here. Our positive or negative supply is going to be here. Yeah, and then this is for the other channel. So this is for one channel. And for plus and minus supply here. Well, with that being said, let me see if I can measure our transistor voltages. Oh, that was just crackling. I thought that was short. Okay, let's measure our transistor voltages. Nothing, 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 nothing. That's nothing. Okay, so one of them we have 43. So I'm gonna go on the other side of this amplifier and we're gonna compare. I think there's something gonna be wrong with one of these channels entirely. So we're gonna go ahead and just put our, yeah, like that. And we're gonna compare. I'm gonna actually put these, I'm gonna put the accessory probe kit on here. Okay, so we're gonna put this guy on here. Be careful not to short anything out. Okay, so let's see what the screws are measuring. 51, 51, 51, 51, 50, 50. Just try to check to see where our reference is to ground, because I'm not sure. I think this is our reference. Let's put this here. Just check. No, so it's not a reference. I have to check because I'm pretty certain I'm using the wrong reference. Where would be? This might be hard to see because I cannot see. Here we go. Let's see, I think it's all the way under here. Here we go. Let's try now. Yeah, here we go. Minus 51. This is correct now. Minus 51. Minus 51. Yeah, minus 51. There we go. So here we have, these are the NPN transistors. Yeah, so these are the NPNs and this is the PNPs. So the reference, I know where it is now. It's going to be right there in the middle. So we got our, yeah, NPN, which is the Sanken C3856, and the PNP, which is the A1492. So the 2SC 3856 and the 2SA 1492. Now if we go to this side, let's see what we find on this side. Now let's see what surprises we find on this side. Maybe it could have just been a blown fuse, who knows? But I think it might be just more than just a blown fuse. So if I'm lucky, it's just a blown fuse, but we'll find out now. See, I don't like that already. Yeah, minus 51, minus 51, minus 51. So I think we have 3 blown outputs right here. That's our issue with this unit. Yeah, because I'm getting garbage readings. And if I compare with the other side, you'll see, actually I can do this with the meter right there. You'll see that these are reading good. Yeah, that's plus 51, plus 51, plus 51. This is what I was saying before, by the way, these pointy probes. They're very nice because with surfaces that might have a hard time contacting between the probe, this will really make your life easier. Yeah, see, minus 7, minus 3. Okay, so I think either the transistor, well, I don't know if they're shorted, because if they were shorted, then why would they not keep the dim bulb on? I think we might have a power supply issue to this unit, so we're gonna investigate a little bit more. But my theory is if I play music through this thing now, this side is gonna work. So let's see. Yeah, see, that's our negative rail. Yeah. Oh no, wait a minute. Yeah, this is our negative rail, and this is supposed to be our positive rail, but the positive rail is not getting power correctly. So if I go here, just to show you, so our positive rail on this side is working. It should be working. Yeah, here we go. Come on. 51, yeah. And then this is our minus rail. Again, this is a bit flimsy because it's not making good contact. There you go. Minus 50. And this is plus 50. Yeah, it's still a bit, the connections are not, well, I know it's going to be this, so if I just go here, yeah, see? 51, yeah. Minus 51. So we have either a power supply issue on this side of the unit over here, or the 3 outputs are shot. But my feeling is they're not shot, because if the outputs were shot, then the fuse would have tripped, but the fuse is not tripped now, at least, and the dim bulb is not glowing. So I really highly doubt that there's an issue with these transistors. I think we have another issue with these transistors. I think we might have either bad connections, or, but still it doesn't explain the fuse was blown. Well, look, I have the old fuse here, and if I look closely at it, it's clearly blown. This is the old fuse. I don't know if you can see it, but it's clearly open. So I'm just thinking now, let me just try one thing here. I'm going to take this guy off. We put him down here, because this is like our, actually, I want to check if this is tied to the chassis, and I think it is. It's not like the Bryston, I think. So we're gonna go here, see if it's like the Bryston. No, see, it's not like the Bryston, it's not, but this one it is. So we're gonna use here as our reference. This should be fine. We're gonna go from here, yeah. This is our reference, and if we go again like here, like I said, this is minus 51. This should be plus 51, but as you can see, we're getting, this rail should be plus 50, but we're getting minus 7.1 whatever 67. Okay, but as a comparison, I'll show you on the working side. This is reading correctly. See, 51. Look where I have my probe. Plus 51 and minus 51. So this side is working like it should. but this side is not. So I think we either have a broken connection or there's actually something that failed catastrophically. I'm not sure. So we're gonna flip this over and we're gonna look on the other side and see what the heck is going on. So let me just put this to the side for now. Turn it off. We're gonna flip it over, we're gonna turn it off, and we're gonna see what the heck is going on the other side, because I think we might have a story to tell on the other side. But it's not blowing the fuse, so it's telling me the fact that the fuse is not blowing, that's also weird. I don't know why this one blew in the first place. And the fuse is not blowing, and dim bulb is not glowing. It's telling me that these transistors are good. They're not shot. So I'm gonna flip the unit over. And we're gonna open up the underside and we might have a story to tell there. So, okay. Might be a story to tell us there. It might be a story for us to say there. Okay, so we'll move these screws. We'll figure out why we are missing power to our unit. Let's see what the heck is. Here we go. Here we go. So, looking for broken connections or cracked solder, but I don't see any of that with this unit. It's a Toyota transformer. Yeah, and as I suspected, because I'm looking right now, the transistors are, the leads are bent upwards, or not upwards I should say, but under here, and you just solder down there to the board. Just looking here. Okay, so let me just check to see again where our caps are. It should be right there in the middle. That's earth. Let me just, because it's under here, I'm just gonna flash my light under there. Yeah, I see where the leads are. So we have number 1 there, number 2 there, and we have number 3, number 4. Those are pretty big caps. Yeah, that's how that is. So, because on the sides, they have these bus bars. Yeah, the fuses, which are right there. Those are the fuses, and right next to the fuses are the caps. Because right next to the caps, there's nothing. It's just, yeah. So I know where this is now. So we have our plus minus. We're gonna take some voltages on here, and we're gonna see what we see. We're gonna look and see what we see. I'm gonna start by the working side, which is here. And we're gonna put our probe, one of our probes here, because I know this is a good reference. And the plug's gonna probably be here now, yeah. So I'm gonna plug this in here. Yeah, the dim bulb glows quickly, but then it drops, which is good. So let's see here. 51, see? 51 minus 51. Okay, so that side is good. We have to check and see now about the not so working side. 50. Okay, so we do have our plus 51. What about our minus 51? Yeah, here we go. So we do have a broken connection somewhere. Interesting. We have a broken connection somewhere. So this is minus 50. And this is our plus 50. That's what I thought. See, minus 51. Plus 50. Yeah, plus 51. Minus 50. Yeah, see? This was supposed to be the bad side, but as you can see, I think we have just a broken connection somewhere. Yeah, see, plus 50, minus 50. Yeah, so on both sides we are getting the right power, but now the question is, why aren't we getting the 50 volts to the transistor? Haha, that's the $1,000,000 question. So this is the working side. We're gonna check here. Yeah, and these are the plates here. So we're gonna see now here 50 minus 50. And if I check here, minus 50, and it should be 50. Yeah, that's good. Now let's go on this side. Now here, this is where we're gonna have some fun. So yeah, why is this reading minus 7? That's not good. Yeah, that's not supposed to be good. That's not right. Yeah, so this is not reading like it should. Why is this reading minus 7? Just looking closely to see if we have any loose or broken connections. Yeah, see 51. There should be 51 too. Minus 7. What the hell is going on here? Yeah, this is 50. This is our 50 volt supply. And this is our minus 50 supply. Yeah, see? But why are we getting, that's not right. This is supposed to be the same. So I think we have an issue with the other fuse as well. Haha. So let's turn this off once again. Flip it back over because I think we got another issue with our other fuse. I swore that was not shorted. I swore it was not shorted. So let's go ahead, flip this over. Let's see. Yeah, see if I'm gonna hold it like this for the time being. It is blown. Haha. It is blown. So this one is no good either. This one we're gonna be very careful how we, because now I have it at this angle and I can see that it's actually not looking too great. So this one is blown as well. So actually, you know what? A different tool. I have one like this. It should be pretty good at doing this. I think it broke though. No, I don't think so. Wait a minute. Wait a minute. Yeah, here we go. These are very nice. These pick tools. These picking tools are quite nice, I have to say. You can get into there. careful because I can see there's, you can easily short this if you're not careful. There you go. This fuse is blown as well. My pliers, and so I hope we don't have shorted transistors. That's not going to be good if we have shorted transistors. So now we're getting closer to the truth. Let's see, 2.5. I'm putting 2.5. I'm putting 2.5 amp fuses for the time being. They're a lot smaller than what they're supposed to be, but for testing purposes, they should be good enough. So, yeah, come on. There you go. So another one that's blown. We have two of them. If you look, yeah, this one's blown. Yeah, you can see the marking right there. See the brown here. You can see that there's a brown spot right there. Yeah, it's blown, and I can see. Then we have to put it on the tester because I can see that it's blown. So let's go ahead. Let's put this one on there, and I'm gonna be a bit careful with this one. We're gonna go and put this guy on here. Yeah, see. I saw some sparks. Now that should be on there. Yeah, that's good. Now, I think this is where we're gonna see some fireworks. So we're gonna put this on the dim bulb once again. And I think we're gonna get a bulb that's dimming. Now watch this. Okay, let's see what happens. No, not even. I heard another click. Really? Was it really just that blown fuses? My God, if that was really the case, then I'm gonna laugh my pants off. Okay, it might have been just a simple case of blown fuses. So, go. That's on, but it turns. It's not staying dim, which is a very good sign. So let's see if we're getting that hocus pocus magic. I don't think so. All right. So do we have our plus and minus 50 volts? This should be minus 50 or plus 50. I don't remember. Here we go. Let's try here. 4138 minus 1. Okay, here we go. That's close, and that's not far apart. Do we get our supplies correctly here? 41 minus 41. Good. Now if we go on the other side, I think because now we have the other channel up, this is going to be a bit lower than 50. Yeah, that's it. Because the other channel is up now, we're not getting 50 anymore. So we have both sides on. So that's telling me, now we found the problem. So the problem basically where we had just two blown fuses. That was the issue with this unit. So we have two blown fuses, and that's what caused our problem. But this is the first time I see fuses that are blown that don't have any other blown components, because usually when fuses like this blow, it either means there was a short on the components, so like power transistors, or it means that either means that the fuses were, if the fuses were blown, it means that there was components, usually power transistors, output transistors that are blown, or there was maybe just a simple overload. I think that's what happened with this unit. There was an overload, and it basically just tripped the fuses. Let me just show you. Yeah, here we go. So what I mean by power transistors, I mean transistors like this. So usually if components like this blow up, or short, this component here would cause the fuse here to blow up, because these are very high powered devices. So when these short and you don't have protection, you can cause a fire. So that's why we got fuses in amplifiers. But okay, that's good news. We're gonna power it down. I'm gonna put some music into this thing, and we're gonna hear and see if we get music out of it. If it's possible, I'm not sure. Let's see. So I'm gonna flip this back over like that. We should be getting. Oh, sorry about that. But I have to be careful because this is a power amplifier, and I don't have. Ooh, what do we have on the back? We have the inputs, but we don't have. Do we have outputs? That's a good question. Let's see. I can put this up here without worrying too much. Left, right. So I'm gonna feed it with a source. I don't have quick. I'm gonna get my speakers. We're gonna hook it up. Yeah, because this is not a preamp. This is a power amplifier. So we don't have headphone amp or anything in this thing. So I'm gonna feed it my source. I'm just gonna grab my speakers that will connect to it, and we're gonna play some non-copyright music so that I don't get taken down, because I've heard too many stories like that happen in the past where copyright music brings music down. Oh boy. Hello. Right now I'm just grabbing my speakers in the back here. You don't see that. Okay, grab one speaker, grab the other. And this is powered off right now. This is not turned on. You're gonna see me connect my speakers up to this thing. Yeah, here we go. So this is, I'm using just bookshelf speakers. Nothing fancy, because this thing doesn't need too much to power on. Let's see, do I have to get this up a lot more? Where's the heck? I see how these things are. There's no hole. It's just using really. These are nice. The banana plug connections. That's one channel. And another thing is, I've seen other people on YouTube. They repaired. So not this exact amp that I've seen, but I know one guy who got a different amp, a tube amplifier, and whoever had the genius design of idea of screwing these down with a socket or something, with pliers or something, that's what happened. A customer of one of the guys I watch on YouTube gave an amplifier for repair, and he basically used a socket to tie these down, to tighten these down. And basically broke the whole thing behind it, you know. So, and the guy on YouTube was like, "Why the hell did why the hell did you do that? You just have to, like I just showed you, just hand tighten these things. You don't need to put a socket or a pair of pliers to it." And like he says, this was actually 12-volt vids. I like 12-volt vids. He has very nice videos. I watch him a lot. And it was the video with the tube amplifier that he had got there, a really weird looking custom tube amplifier. And basically what happened to him was his customer had tightened these posts down with like a plier or something, and they broke in whatever was behind it, you know. So it was pretty foolish, but he managed to fix it. So it's up on his channel. It's one of his latest videos that I've seen now. But anyways, so we're gonna plug in. I just notice the problem. The inputs are far apart, so we're gonna test one at a time. I guess we have no choice. So I'm gonna go ahead. I'm gonna plug it into my tablet because I'm filming this video with my iPhone. So I'm gonna plug this in with my tablet, and we are going to go on YouTube's. Make sure my volume is low. I'm gonna say, oh, not now, non-copyright free music. So here, we got some copyright free music. I'm gonna power this thing up again. There you go. Really clicked. Here we go. Yep, I hear music. So I'm gonna bring this up now for you. Yeah. Not sure if you can hear that, but we got music coming out. Yep. Let me put this a bit higher. I'm just gonna make you guys hear it. So this is, I'm testing this channel, the right channel, and it's working. So the right channel is working. Let's try the left channel. And this should be working. So the right channel was the one that seemed to be a bit faulty originally, but we're gonna check the left one right now. So there you have it, and I would say this thing is fixed. So I'm not going to keep these fuses in because these are not rated for the right spec, because the fuses that are here are rated for 2.5 amps instead of the 5 amps. Yeah, so I'm gonna need to get 5 amp fuses for this thing because I do not have those fuses here, unfortunately. So I'm gonna get, it's 5 amp slow blow 250 volts. So I'm just gonna get those fuses, put them in. I put these ones in just for testing purposes, but looks like everything's working now. So I'm gonna probably wrap it up over here because I don't have to continue. It's fixed. I'm just gonna put this aside. So yeah, and I'm gonna see how this video turns out because this is the first time that I film it like this with the camera above. But yeah, let me know. Hopefully this is better for you guys and for those that complain out there that, oh, my camera, it's not stable, it's shaking too much or whatever. Okay, fine, whatever, you know. So hopefully this is going to be a lot better, and hopefully you appreciate it. But anyways, I'm gonna leave it at that. I'm gonna let the customer know the good news, and he'll be happy with this repair. So, with that being said, if you guys like the video, please leave a thumbs up, put a comment down in the bleep bloop section below, and make sure you're subscribed to the channel so that you don't miss any new videos, and hit the bell, because with the bell you can get informed whenever I upload a new video, and you'll basically never miss a new video when I do upload it. So, as always, thank you for watching, and we'll see you on the next one. Okay? Bye-bye.